You know, after a hard day at work, I really would like a drink of water. Oh, but it was a really bad day. Maybe a glass of red wine would be better. Hmm, red wine. Oh, flush. Hmm, you know what? Maybe white wine would actually be the way I want to go. Yeah. But I almost feel like celebrating a little bit because I got done with the day. What about some champagne? Oh yeah. Mmm. Oh, but do I really want alcohol at the end of the day? I'm about ready to go to bed. Hmm. How about a nice glass of milk? Oh, I almost feel like I need something kind of sweet though. You know what I haven't had forever is those orange Julius's at the mall. Yum. Oh, but then that's a little too acidic for the end of the day. Hmm, maybe a nice strawberry milkshake would be the best. Oh, gosh. After thinking about all of this, I think I just want a nice Coke. So let me go through how these were made. So first of all, we need to make a sodium hydroxide solution. So this is solid sodium hydroxide. And we're going to put it in some water. And it will dissolve and create our sodium hydroxide. So all of that will go away. All right, so we're all dissolved now. So sodium hydroxide is completely now an aqueous solution. And that's actually going to be our first drink. So that is our water. So that was the water. So that was the sodium hydroxide, and sodium hydroxide is a base. So my next cup contains phenolphthalein, which is an indicator, which all of you guys used in the lab this week. And that's all I did too. So there was a few drops of it in there. So when I pour my base into this, it's going to turn it pink, of course, because phenolphthalein turns red with a base. The next cup had sulfuric acid in it, which you might have been able to see. It didn't take very much, just a few drops. And the sulfuric acid is going to react with the base and basically change the solution. Oops, I got a little bit too much. That didn't happen on the last time, so we'll fix that here. My white wine, maybe. There we go. Didn't add enough sulfuric acid that time. All right, the champagne for the bubbles. You guys did this one in your precipitation lab. So this is sodium bicarb. This is a solid. So it's just a little kind of crystalline, just baking soda basically. And I'm going to create an aqueous solution with it. You might have been able to see that in there. And so when the sulfuric acid reacts with the sodium bicarb, we get the fizzing. And it's producing carbon dioxide. All right, the next cup was the milk. And in the milk was barium chloride. And I think you did this is just a precipitation reaction, which you also did in your last lab. So I'm going to now take our champagne and pour it into, and it creates that white precipitate of, actually it's the carbonate that's in here. It's going to create barium carbonate, and I'll write the reactions for you when I go through this. So that's how we made the milk. Now, in the Orange Julius, there was just a little bit of these crystals in there, and that's why I had to use a brown glass. So this is sodium dichromate. And we just had a few crystals in there. And it's going to do a chemical reaction, which causes a bunch of fizzing. And then you still kind of have the precipitate, so it causes it to look more orange juicy and very pulpy, or like I mentioned, an Orange Julius. Oops, I forgot to put the little card. There we go. So that was sodium dichromate in that one. And then our last one, the pink milkshake, all I did was use the same sodium hydroxide solution that we had last time, that I already previously made, and I just added a little bit more in here because we still have phenolphthalein in here. So when I transfer it to this cup, that phenolphthalein, oops, boy, I'm really messing up here. Oh, because of all the sulfuric acid I added. All right. Is that gonna make it go pink? Oh, yep. So there's the pink of the sodium hydroxide, again reacting with the phenolphthalein. Obviously, I did the real one much better than this explanation. And then, of course, all I did was switch for a Coke because that was funny. Haha. All right, chemical reactions are cool.